Long-term data storage is under pressure. As data volumes surge, the challenge is no longer just storing information. It is preserving it for decades, efficiently, securely, and at scale. Holomem is taking a radically different approach. Let's dive into the conversation.
Hello, my name's Ray Quattramini from Fortuna Data. Welcome to Smarter Strategic Thinking. Today we have Charlie Gale from Holomem. I've met you before. I've been to your premise in London. Tell me a little bit about your background and story.
I guess I'm a self-described inventor, and I've always had somewhat of a love affair with optical technology. So at university, I developed and patented a holographic road sign. And of course, as a 21-year-old, was convinced I was about to change the world. Went out trying to sell these novel road signage devices. There was no market, but it really got me interested in what can be achieved with multi-layer optics. It continued throughout my career. I took a job at Dyson in products innovation, where I worked for just under 10 years, kind of in the think tank of what can you do, what prototypes can you make, how can we protect these, and how can we bring kind of disruptive technology to the market. But this interest in optical technology led to holographic labels. In the world of holography, all real kind of money has been made in these holographic stickers that you put on DVDs, banknotes, you name it. And these shiny stickers are meant to prove that something is real. But they're analog. You're just looking at a label. What we did was put machine-readable data in a hologram, multi-layer machine-readable data. So QR codes that are stacked on top of each other in a hologram, and they can be scanned and digitally verified, which is great. We have patented those. We sell them. We put them on whiskey bottles, you name it. But in lockdown, the question was, that the team and I that had built this, how small can we make machine-readable holograms, and how many layers can we add to them? Because ultimately, you're going to end up with an incredibly high-fidelity optical data storage technique. This is by no means a new theory. The thesis of holographic data storage has existed for a very long time. There's a Wikipedia page dedicated to it. But me and my team rather arrogantly thought that we've done this before, we can do it again. How hard could it be to make a working, tangible, demonstrable holographic data storage drive? Holomem was born.
Do you want to tell our viewers a little bit about what Holomem is and how it works? Because let's see here, we have what is an LTO tape but contains Holomem.
So the journey began for us really seeing how we could record large amounts of data in incredibly small spaces. And I mean, holographic data storage, the reasons that people kind of get attracted to this is it's long been kind of heralded as the holy grail of ultra-high density, long life, robust archival data storage. And the reason for being is that you use polymer-based materials to store very small images of data, so kind of binary dot matrix codes. The first thing Holomem did in our original lab, it was a garage in Acton, was built a large optical table where we had lasers, lenses, you name it. Wow. It was 3 meters long, this thing was. We actually had a huge lithography lens that had stamped on the side, made in West Germany, which gives you an idea as to its age. Big rig, but what it made was a small sample of a polymer film that we had recorded the album Random Access Memories by Daft Punk onto. So
wow,
small 1-inch square, full album. And I took that home, I put it in the oven with my dinner that night, cooked it, brought it in the next day, and we replayed the album from that small piece of film. So the whole kind of thesis of having a high-density, ultra-robust data storage technique using a low-cost polymer film was proven by this very big system. The journey from there, I mean, that was some 3 years ago now, has been pretty much operating in total stealth mode as a company. We're just a team based in West London as kind of a group of hardware junkies that have taken the kind of the holographic theories and innovations that were built on that table to now a consolidated, automated data storage drive. So all of those lenses, lasers have been brought into a unit. We call it the holodrive. And the film that it writes on, that same polymer film, we've taken away from a 1-inch square of it, and we've put it into a cartridge that's compatible with LTO infrastructure. So within our cartridge, we have a light-sensitive polymer film in that same shape of cartridge where we can store more data. It's longer life. This is guaranteed 50 years of storage, and it's just incredibly robust. We talk about it as it's the cockroach of data storage, right? So when it comes to thermal fluctuation, humidity fluctuation, this material was actually developed for automotive applications. So it's incredibly resilient to thermal change and humidity change. So we're saying no active management of its storage environment is required.
That's really interesting. What are the benefits of Holomem after traditional LTO tape? Because as far as I can tell, you're going after the true archival market.
I mean, so we're talking about cold data storage and archival data storage, right? And as you're probably aware, I mean, the headwinds that are being faced by the industry at the moment are just ginormous. I mean, data storage, original data creation is growing exponentially. All existing storage tiers are being pushed to their limits. So you see these huge price surges taking place across flash, hard disk drives, and magnetic tape, because it's a struggle for capacity, ultimately. Magnetic tape is seeing somewhat of a renaissance era, where it was maybe previously considered somewhat a vintage technology, but tape is incredibly beneficial. I mean, it's ultra low cost, ultra high capacity storage. What Holomem can bring to the table is kind of even more capacity and even more robustness in the media. So we've been intentionally modeling our drive, our cartridge, and our general format around the existing infrastructure that's used with magnetic tapes. So our cartridge being compatible with existing LTO infrastructure is a very intentional move, because there's so much of this hardware already out there, and we want to be a low friction kind of complementary companion product to existing magnetic tape. We're in the world of deep archive. Our media is write once media, so we are unapologetically worm. We are immutable at a media level. That's perfect for long-term archive. Our cartridges and our drives can work in parallel with existing LTO drives and cartridges within the same library. So I think lots of users that already have large data sets that they're keeping on tape, we can offer an additional tier of storage that works with their existing infrastructure, plug and play, but gives them additional capabilities for their extra long-term data sets.
The current issue with LTO, which we're all familiar with, is every so many generations you have to upgrade LTO, you have to move to the next generation because of its backwards read compatibility, and your product overcomes that.
Yeah. I mean, so magnetic tape, they have, we're on LTO 10 now, right? So it's been running since the early 2000s in its generations, always stepping up capacity. And it's incredible, and their roadmap will continue to do so. The challenge they have is, by virtue of having a magnetic head that writes and reads and improving that head design and improving the media, the generations of drive and cartridge are intrinsically linked. There was once kind of a ability to be somewhat backwards compatible for a few generations. The latest generations are not, so they're always linked. The benefit we get at Holomem, because we are an optical data storage system, is our write head and our read head are not going to be locked to the generation of film that we use. So we will always be backwards compatible with our media. It also allows us to be able to offer a bit more flexibility with our drive formats. So traditional LTO is always a write and read system together. Because our holographic write engine and the technique we use to read holograms are separate, we can actually execute a classic write-read drive, but also a read-only drive.
Okay.
The benefit for us is that's a much lower cost system to be able to produce and represent. And it also offers the customers then an opportunity to have much greater read throughput in their system. You'll know in these LTO libraries, you have so many slots available for the drives that are normally not utilized because the drive cost is so high. We can say you can fill these now with Holomem read-only drives and offer yourself so much greater read throughput, which for the high-performance compute kind of group and other hyperscalers is such an interesting use case.
One of the things that is interesting about LTO is obviously we've got LTO 10, which currently holds 30 terabytes natively. We've got LTO 10E that gives you 40 terabytes natively. But where are you going with your capacity roadmap? Because you mentioned it's capacity. Everyone needs to store something sometime.
One of the core virtues of holographic is such great data density because you can do multi-layer storage. What Holomem's looking to do is bring out its first product in 2028, which will be a 50 terabyte cartridge. So looking to kind of go toe for toe with the latest generation tape, but offer that greater long life in storage and much more resilient and robust media. From there, our roadmap to higher capacities is really strong because we're adding more and more layers to our data density. So we deal with multiples rather than kind of organic growth. So we see line of sight to hundreds of terabytes per cartridge, if that's what the market is interested in.
In my career, I've come across many organizations that are storing data. Well, many years ago, they stored them on NetApp. One springs to mind was the Coal Authority. They bought an optical archive. I think it was DVD at the time. And they kept it on there. And then they moved it to the cloud. But there's a lot of noise and a lot of movement at the moment about the US Cloud Act, about where GDPR and data sovereignty begins and ends. Because if you read the Cloud Act, where it ends in terms of how secure is your data. And as far as I'm concerned, this could sit on a shelf and no one can access it. From my perspective, your product is a very long-term archival device that is offline, so can't be hacked, can't be tampered with, and it's worm, so you can't even edit it or change it or anything. So your device, in terms of the cost and what it brings to the market, especially for archives, like I've worked with the BBC Archives before, I've worked with very many archival organisations over the years. Yours is like the panacea. I know there's some other, if you want to say about other technologies that are out there, then what are your thoughts in terms of where the market will go from an archival perspective?
Original data creation is not going anywhere, right? It's growing exponentially. Yeah. And our desire to store our existing data for ever longer periods of time is also not going anywhere. And you even look at the National Archives that are still digitizing lots of their collections. The desire for ultra long life, ultra low total cost of ownership storage is really increasing. So it's maybe the lesser told part of the industry when everyone's getting kind of very excited about ultra high performance flash storage. What we're really looking to cater for is kind of, we sometimes call it you talk about the AI boom and data creation skyrocketing. We're here for the hangover of all the data creation that comes afterwards.
They're going to put it somewhere, aren't they?
Going to have to put it somewhere. So this air-gapped, ultra resilient, ultra low cost, stable data storage is where all that data goes eventually.
Another question that always interests me is data archivists. They've got petabytes of data, the BBC Archives being one of them, National Gallery being another, Imperial War Museum another. And this data doesn't need to be altered. It's history. So how can Holomem help those organisations in terms of data migration from what they've got? Because they're not all on LTO tape. How can they help them move to Holomem, for example?
I think there's two parts to it, really. I mean, we're talking about these kind of really important data sets. We need to retain this data, and to lose it is unthinkable. And with existing generations or tiers of data storage, the anxiety about losing this information, and you hear the term data rot being used in the industry a lot, is a real concern and results in a much higher total cost of ownership for managing these data sets. Large amounts of cooling are used to maintain archival libraries. There's a general dichotomy of you want to check that your data set is okay on magnetic tapes, so you want to read the tapes to verify it's still there, but reading the tapes accelerates the data rot. And I was once given the analogy of checking your archive is a bit like checking if your red wine has been corked. By the time you find out, it's too late. What Holomem offers is a much more robust media, so it doesn't require any active management in its archival state. There's no data rot, and reading the cartridges doesn't damage the data set at all. So it's far more kind of risk-free, long-term data storage. What's more, I think archivists face this challenge that there will often be on existing generations of magnetic tape, right? So they have their library, their cartridges, and their drives. They need additional capacity, but to move to the latest generations of tapes, they have to rip out all of their existing stuff and bring in the new, because the cartridges and the drives are linked in generations. Whereas Holomem, we will be able to bring additional cartridge capacities to customers without having to change the drive. So the upfront capex will be that much lower. So it's a future fit data storage tier.
One of the other questions that a lot of organizations face is where to put their data. And currently, a lot of them moved away from tape because of its capacity and the incremental changes and upgrade of drives and next generation, everything else. And they put it in the cloud. And we all know storing archive data in the cloud, whilst it might seem a good idea, is, weighs heavy on your pocket.
Correct.
Every month you've got to pay, and if somebody ups their price by 10%, guess what? You're paying an extra 10%. And on top of that, you've got the ingress charges of putting it up there, the egress charges of getting it out, and that adds up. So what are your thoughts on long-term cloud archiving?
Part of the context here is that hyperscalers also use tape, right? It's not often declared or acknowledged, but yeah, all of the hyperscalers will have the same 3 tiers of storage at their disposal. And in fact, AWS just announced that they're building a 20,000 square foot tape-only data center here in Hemel Hempstead in the UK in the coming years. So it's called Glacier. They won't call it tape up front, but that is exactly what they're doing, because tape is still in a class of its own when it comes to this low-cost, long-life data storage. What Holomem offers is just, a companion product that plays nice with that existing infrastructure, but offers lower total cost of ownership, lower OPEX costs, and hopefully then represents to the customer a lower ingress and egress fee as well.
Exactly. Because, a lot of organizations, they have not terabytes, but multi-petabytes of data. And where they put that data, someone say, it's going to be good for 20 years or 10 years, whatever, and I'm not going to be around. That's typically what they say.
Totally.
And it's probably true. Or, they get a data breach and they get fired and they move on, and then somebody else is left to pick up the pieces. And no one really has, from my experience, a clear strategy about data archiving. And I think Holomem as a technology solves a lot of those dilemmas that companies face, and also from an OPEX cost. It's very green. LTO is very green. It can sit on a shelf. You don't have to keep it in a library with fans spinning all the time. And it doesn't take any cooling or heating or whatever it happens to be. So that's where I see Holomem taking a front foot, if you like. So from your perspective, what other competing technologies are you seeing in the market as a replacement for tape, for example?
It needs to be said that we're not the only show in town. We're also not the only company that believes the future is optical when it comes to long-term archive. Since Holomem has formed, I think there's at least a half a dozen new players that have entered the scene, and we share their view and their vision that there needs to be a new tier of long-term archival storage technology that tackles some of these issues about capacity, about robustness, and about kind of operational costs with long-term archive. The difference that Holomem brings to the table is this plug-and-play kind of low-friction approach to working with existing infrastructure and protocols. You'll see projects that are talking about long-term glass storage, kind of flat platter storage.
Silica
and they've achieved incredible things. They present as research projects using research-grade equipment. So whilst there might be an amazing result in a lab, how that actually results in representing a benefit to a customer at cost and being deployable to an existing operational environment is yet to be seen. I mean, Holomem has very intentionally looked to develop a product, not a project. So the HoloDrive is using off-the-shelf, low-cost components. Our drive and our cartridge are compatible with existing infrastructure. And to really demonstrate this, we are now being quite front-footed with pilot deployments of our system. So late last year, we took the HoloDrive, we built it into an existing tape library, and we deployed it to a data center. So working fully autonomously in an operational environment as a working system for long-term archive.
So you can get some MTBF figures.
Correct.
And are you, to the viewers looking at this video, are you actually looking for pilots, large pilots, trial your product?
Yeah, we love getting out there. We love learning. The fact that the HoloDrive is live now, we have these systems. They just about fit in the boot of my car, and so we're looking to be really engaging with the community. So we have archivists, we have the high performance compute industry. We've got some fantastic connections, but we're always looking for more to demonstrate our use cases, demonstrate how credible and robust our technology is.
How should industry leaders talk about or think about data permanence, especially organizations that are creating sensitive data? It could be nuclear data, it could be intellectual property data. How do you think they should be tackling this challenge themselves, 5 or 10 years from now, or even 20 years from now? Because if I had a crystal ball when I first started in this industry, I would never have imagined it to do what it has actually done and become. So what are your sort of thoughts on that?
Many archival data sets are not just a nice to have, it's a requirement. So that there are regulations around the long-term storage of certain data sets. And you'll know LTO actually comes in two flavors at the moment.
Yeah.
There's the rewritable cartridge and there's the premium worm cartridge, when you are required and regulated to store an immutable data set for a long period of time. You use the worm LTO cartridges. With Holomem, you get the worm for free. So all of our cartridges are worm. We're unapologetically worm. And so to have that data set immutable at a media level means that it's so relevant for long-term archives. We're talking about banking records, medical records, all forms of regulated data sets.
One of the interesting subjects that's come to light, and I deal with a number of organisations, but one in particular springs to mind, is everyone's talking about the AI boom. We're looking at AI, but something resonated with me a few weeks ago. Whereas this guy who I deal with, he said the problem for us is we don't have our data in one place. It's on spinning disk, it's on RAM, it's in the cloud, it's all over the place, and trying to get all this data together in one place is quite important. So from my perspective, your technology would be able to store that original AI data set unaltered. So if something happened from a compliance point of view, a legality point of view, a data breach point of view, then you have a reference.
AIs need to feed on large models and large data sets to inform their decisions. And I think having an immutable data set and using our technology as an active archive for AI to draw into and feed from is incredibly powerful. And you're right, the fact that it's truly immutable and non-modifiable actually works as an advantage in that use case.
So your technology, what's your roadmap to deliver? So for people looking at this, they're obviously planning 5-10 years in advance. What's your delivery roadmap? Obviously you've mentioned that you're looking for active pilots. Where are you in terms of your actual deliverables?
Holomem's a deep tech hardware startup, right? And since forming, we've been building systems, building drives to prove that what we're saying is real and that it works. We finished last year with our first public deployment of our system, as we say, to a data center here in the UK. That is our proof of concept holodrive system with the cartridges that work with it. Our journey now is to continue these pilots. So throughout 2026, beginning of 2027, we're going to be tapping into all of our end users and kind of scenarios where we think the holodrive really shines through with its performance, to build that credibility and build these relationships in the market before ramp up and entry to the market in 2028.
One of the things that has always fascinated me to a certain extent is, in order for your holodrive to work, you obviously have to have a SAS interface or a fiber channel interface, and it's the software vendors, the ISVs, that you need to get certified with. Or are you gonna, is that something that you're currently engaged with as well, in getting ISV certifications from all these vendors?
We realise we're part of an ecosystem here, right?
And, exactly.
We very much want to play within that rather than redefine it. We want the holodrive and our Holomem cartridges to be usable in the same way that people use existing LTO infrastructure. So we're partnering with the existing software vendors, the existing library manufacturers, so you can really use Holomem as an alternative to LTO or even in companion with LTO. Yeah. This is evolution, not revolution.
Yeah, and I can see mega benefits in this, because obviously you've got your LTO tape for backup, for fast restores, for your air gap, and then you've got, in the same library effectively, you've got your long-term archive.
Exactly, and it's horses for courses. There's real benefits to what LTO can currently offer with its ability to be rewritten as well for backup.
Yeah.
That will always be a good product. We're here for the long-term archival data sets, which is actually the largest growing amount of data requirement there is. But no, to have these as companion products is actually incredibly valuable.
Yeah, and the software vendors that you mentioned, they should be able to take advantage of. That's for backup, that's for archive.
Totally.
They should be able to differentiate between this because it's quite important. If you had one piece of advice to give to leaders today, obviously we can't prevent data growth, but what advice would you give to them? I've got a little opinion on this, but you can, how do you think they should be looking at the future?
I mean, I guess Holomem's here to say, rock on with data generation. We're here for it. I think data is one of our greatest assets as a civilization, right? And it can be so beneficial and so powerful. What we need to make sure is the way that we're managing and storing that data is sustainable and practical. And currently, the infrastructure is simply not sustainable throughout the entire stack, right? So you look at day-to-day bandwidth operations, how data centers are struggling to keep pace. Holomem in its sector, in this kind of long-term archival sector, is here just to breathe new life and new capacity and ultimately present a future-fit solution.
Yeah, I agree. But also a lot of organisations, especially in light of what's happening with market forces that are outside our control. So, for example, WD have announced that they're not selling any, everything they make now is sold out to 2027, which is ridiculous, And the part of the issue is, I think a lot of business leaders think, oh, we could just go and buy it. But what even if you place an order today for an NVMe drive, you may or may not get that drive for 6 months. So the pressures on storing data, everyone's creating it every day. This video's creating data. Everything is becoming increasingly complex, and having something that you can actually free up that tier of storage makes a lot of sense.
Heard anecdotally that some flash storage is worth more than its weight in gold these days. So data really is the new gold. I think what Holomem really is presenting here, given that we are using a low-cost, abundant polymer to store data, it really kind of it takes the sting out of these the cost and the energy required to store these ginormous data sets.
Yeah, absolutely. And it's we've got 8K videos. They consume hundreds of terabytes. There's a lot of applications for an archive that people may not consider or may not think of.
Yeah.
But I think, from my perspective, your technology could make this the next step in terms of archiving data and moving it off very easily, without a lot of complexity. We're not talking about reinventing the wheel, are we?
Totally. And I think there's somewhat of a stigma associated with archival infrastructure and data, that it's somewhat dusty and old school. I view it totally differently. I think this is actually some of the most kind of interesting parts of the ecosystem, and actually there's going to be more innovation happening here than anywhere else. I mean, archival data sets and the utilization of existing archival hardware is growing like never before, and so I think Holomem's really here to bring innovation back to archival data storage.
I think a lot of organisations, when I've spoken to them, they say, we back up everything. But that's all well and good, but that costs some money. Whether it's on hard disk, whether it's on tape, whether it's in the cloud, they back up everything. So they're not actually looking at it from a point of view as how can I actually save some money long term. Data, what's the statistic? Data after 2 years, 80% of it's never accessed again. Yeah. But we'll still back it up, and that's where I can't understand the mindset of organisations, where they should be looking at data as an asset. So if you're accessing data daily, that needs to be on primary storage. If you're accessing it once every 6 months, maybe you've got that on hard disks. But if you're accessing data once every 10 years, then why are you keeping it in the cloud? Why are you keeping it on spinning disk? Why are you backing it up?
And I think if we can offer functionality and kind of flexibility to allow this kind of the decision makers to really trust an additional tier of storage that offers these lower costs and offers these reliabilities and reassurances, then hopefully we can start to inform change.
Brilliant. Well, thank you, everybody. I hope you enjoyed that from Holomem. Charlie, thank you very much.
Thank you, Ray.
Take care.
Cheers.